briefly talk about the audio SDK, then go into the format SDK, and then cover the technical details of the rights management system. This has already been covered, the different SDKs. So last summer we shipped the audio SDK, and it went into beta in the spring, and there have been thousands of downloads of it and hundreds of applications built on top of it, and a few of the screenshots of the more popular ones are shown here that have already been discussed today. So right now we have in beta the format SDK, and that'll be released very shortly. And this is the first time we have a full, complete SDK that exposes all the features of the Windows media file format that Ramiro discussed. So not only can you read and write everything, also the networking code has been put into the SDK so that you can write applications that stream out to the net. You can write applications players just like our own Windows media player that receive streams from the net. And expose all the content, description properties, markers are textual, just chapter headings that you can put in the header of a file so that the user can easily jump to a specific segment of a video or audio clip. Then the script stream has been exposed. And as Ramiro mentioned, this script stream basically, along with audio and video, it's really useful often to have timed pieces of text that are synchronized with a particular point in the video to make an URL flip happen. But the problem with that is often the amount of text compared to the audio and video data is very, very small. And so, depending on how much text you have, you'll either want to allocate some bandwidth to it and actually create an actual stream, or alternatively, you can take all the text of all those events and move it up into the header. And in that case, the header is slightly bigger, and there'll be a slightly, barely noticeable, detectable longer time to download the header up front. But then afterwards, you have the full bandwidth available to the audio and video. And I'll show you later how you can do that trade-off. Okay, and the rights management system that we have and the portable device support. So in this SDK, there's all the support you need to move content out to a portable device. And in the next talk, I'm going to get into a lot more detail about the firmware that you put onto a portable device that supports the decryption of protected content. But in this SDK, this is targeted at people writing applications on the PC that have, as one of their functions, the ability to move a piece of protected content out to the device, and show you how that fits in. So we've kind of gone through this, but the types of applications you can build, and I'll refer back to these as I go through the interfaces to discuss which parts of the SDK each of these will need. So this is a high-level diagram showing what we're talking about. On the encoding side, you'll be passing in typically passing in uncompressed audio. So that's samples, the actual values of the waveform. Samples, something like 44,000 samples per second for both channels. And if you ever use the waveform at the X structure, that's exactly the form of the data that we expect. And similarly for video data, you're going to be passing in frames of video, which are just bitmaps that are laid out with all the video data. So the SDK accepts that as input, and it then calls the codec to compress it. And after it's been compressed, it writes out the file. Or alternatively, at the same time, you can tell us that you want the file to be protected, in which case we'll call out and get to the DRM subsystem, and that will encrypt the compressed data and write it back into the file. And in this example, I've been saying that you're passing in uncompressed data, so I'll get to later. There's an advanced form of the interfaces where you can access the actual compressed data, which you need to do for certain, typically editing scenarios. So anyway, once you've got the Windows Media format file, you can either tell us to write the file directly to disk, or you can indicate a URL to distribute it to, or you can indicate a port that should be opened up on the encoding machine that the server can come back to and connect to. And all that, we have APIs that enable all that. The encoding application doesn't have to worry about any of the networking details. It just tells us what to do. So then on the playback side, it's essentially the reverse. And obviously, this could all be on one machine in one application. We receive the stream off the network or read a file off disk. then we'll first call the DRM subsystem to decrypt it, checking for a license before we do that, which I'll get into. Then we call the codec, uncompress it, and hand you out the uncompressed data for the player to render. Okay, so in order to compress, there are a whole lot of settings that need to be indicated or can be indicated. A lot of them are optional, and we'll choose optimal default. But there's a whole lot of settings involved, and there's been a lot of effort that's gone into tuning and optimizing this so that you can get, for example, the optimal allocation between audio and video. For if you have 100 kilobits total, if you have 100 kilobits total, then how much to devote to audio and how much to video. And so we have created this concept called a profile, which is an object that contains all the settings for everything you need to create all the streams. So when you create a profile, you'll indicate how many streams are going to be in the Windows Media file, what type each one is, whether it's audio, video, or script. And as we said before, script really means these timed pieces of text, snippets of text that are laid out to stream. Then for an audio stream, you tell us what codec to use. And of course, as you've been hearing all day today, the Windows Media Audio Codec, we're really proud of this technology and believe it surpasses by a long shot all the other codecs. So that's the one we recommend. But you can use the SDK if you have to, or need to, or for some legacy reason need to use another codec. You can indicate that to us. And just tell us the format of the data that you're going to be passing in using a WAV format EX structure, and tell us the bit rate that you want us to compress to. And it's very simple, all these settings, and basically that will give us all the information we need to configure the codec to run for audio. So for video, it's more or less the same thing. Again, we recommend that you use our MPEG-4 version 3 codec that's been demonstrated today. And here you can indicate the source, the bit maps that you'll be passing in are going to be one of these formats. And the point of having so many is that if the source material is, for whatever reason, in one of these formats, we don't want to force you to reconvert it and waste all the performance of the CPU just twiddling bitmaps around. So this is really handy, so you can just pass in, if your source material is YUV, you can pass it directly in, the codec accepts it directly and starts operating right on that data. And indicate the bit rate for video, and there's no limit at either end for that. The codec will just do the best job it can. And say that there are a few more settings like the size of the picture that you want, and the frames per second, and the maximum keyframe spacing. And I'm going to show you in just a sec how you can find out all the different things that you can set. The other thing that's in the profile is before we discussed intelligent streaming, which is when you create a piece of content that has video encoded at multiple bit rates so that the content is much more scalable. Just to reiterate, within each band, even these video bands, you'll re-encode at multiple bit rates, a fairly wide spacing. Within a particular band, there's still a lot of effort that's made in terms of thinning, so that overall you can get really good scaling all the way down from modem rates all the way up to broadband with one piece of content. But anyway, in order for the SDK to know what to do and know exactly what you want, you will need to indicate how many of those bands to have and what bit rate each one of them should be. So a profile can be persisted as XML, and as I said, creating a profile creating an optimal profile is a lot of work if you're starting from scratch. And so what we've done is we're shipping a set of system profiles. And this is an XML file. I can just, it's a Unicode XML file, and so I'm just using Word here because it's a nice Unicode editor. And what's nice, what I think is just really great as a programmer who's been using this SDK, is the fact that the solvers didn't just compile all these settings into the DLL and make it opaque so that when I say I want ISDN video, for example, what's the SDK actually doing? I can go in here. Well, first I should indicate this file is called wmsysperf.prx, and it's in the Windows directory. And I've just made a copy of it here and opened it up in Word. But you'll find it in the Windows directory, and it's just this text file. And so what's nice is I can go in here and I can just see if I say here, the first profile I'm looking at is for dial-up modems for ISDN, and I think Amir was talking before about, I believe in total we did that about 37. We optimized for about 37, but as we go in here and dig into the details, we can see exactly what it will really do. So if you want to know exactly what you're going to get, go down here and you can see, like, here I'm at the first stream. I don't know if everybody can read in here, but I've got stream number 1, and that's going to be audio, and it's devoting 8 kilobits for the audio. Then I keep going down, and I can see here on the end channels is 1, so I'm getting mono. We keep going down here, and okay, so stream 2 is a video stream, and its bit rate here is 7 kilobits. So 7 plus 8, that's 15 total. So over ISDN, obviously that's not using all the bandwidth. So if I keep going down, I should expect to see some more video streams that are of a higher bit rates that will be called into use if the bandwidth is available. So let's just keep going down here. Yeah, here we go. Here's the next video with bit rate of 11 kilobits. And anyway, obviously I could pull this up in the XML editor and it'd be easier to navigate around. But what's nice is I can see all the different properties that I'm able to set. For example, you know, the frame size, the average time per frame. I'm just reading off of here the video size for each of them. The compression here is the MP43, so obviously this profile is using the MPEG-4v3 codec that I've indicated is the default. So what I would say is, I mean, obviously don't edit this file because this goes out with the SDK, and people using the SDK won't have your edits. But take a look at it and see what we've done, and either find the profile that you want to use or use it as a template for a new profile. And it also can be used to develop a better understanding of how the encoder tool works, because it uses these same profiles, and this will show you, because some of these properties aren't available, aren't shown in the UI, so this kind of digs in and gets to it. Okay. So I'm going to just delve a little bit into the actual interfaces that are involved. It's not, we've been stressing over again, people can integrate this very, very easily, partly because of the sample apps that we have, but it's also because the interfaces are very simple and very modular, and you don't have to learn about everything if you're trying to do something very simple. So these are the objects that are in the SDK. There's a writer object, which you instantiate if you want to write a file, a reader if you want to read the file. And these are all COM interfaces. The SDK is actually not a class factory, so you don't have to call co-create instance and you don't have to have this DLL registered. You just statically, it's a DLL, and you just load the DLL and, link to the DLL and call a static member function in the DLL to instantiate each of these, and those APIs are right in the header file. So there's a writer object, a reader object, a metadata editor object. That's for editing those header properties, like adding markers and finding out what the title is, finding out what setting what the title is, and so forth. There's a profile manager object, which lets you enumerate all the profiles that were in that PRX file that I was just looking at. And off this are actual profile. There's an iProfile interface that lets you set all of the settings for each of those profiles. Then there's a file sync object for writing to a file, and network sync for configuring all the network settings to stream data out to the net. Okay, so I want to just show a couple of the sample apps that we got. So over here. First, there's this one gotcha, which is that you need to have the wmkey.h file and wmkey.lib file. And these, as Ramiro said, these get emailed to you, so they're not in the default install, so just remember to get those into the right directories. Anyway, I've already built the sample, but one of them is called ABI to WMV, which these are just command line apps. The point is not that these are spectacular apps, but that they're very simple apps. The code there's not very much code here, but they show you how to write out a file. What this guy does is, if I just dump out with no arguments, he goes through and he enumerates all the profiles, and this is just its numbering system, but it's numbered them all here, and it has a simple command line. So I'm just going to go ABI to WMV-I. And then I'll pick a profile. I'll do 100K video. And in fact, I will just go ahead, and this is actually a 200 megabyte source file. It's all uncompressed AVI. That's about a minute long or something, and it's going to just cook through here and compress that. So the other samples, we've got a sample that shows you how to play content, another sample that shows you how to create and manage profiles. And then there are a few more samples that cover the whole WMDM system, which I'll be talking about a little bit later. So this is really the point here, is that it's real, it exists, and it's ready. So I got the file here. I can just play it now. Just created it. Just bring up media player. Hello. Well. Not sure what happened there. Oh, well, I didn't want it complete. In any case, I'll just. This is one I ran right before the talk, so it's the AVI that was just compressed.
But
So
I believe we can ill afford
anyway,
to lose
the point of it
now.
is, that has all the code that you need. It's in this app right here. All the code you need to create an app that writes out Windows Media. And the converse of that is the player. Here, I'll show you. We have an app WMS play, and I can tell it to go and play something, play a Windows Media file, and it'll go and do that. That's all coming from the sample app. So I can then go in here, and all the code is right here, ready to be incorporated into a much more full-featured application. Just want to point out, because it's going to come up in a sec, there is down here, the code, all the code is in here that handles the on status method is all the messages that the SDK will send back to you when the app's running to tell you about how things are going. For example, when buffering starts, when buffering is ended, and that, I mean, in our player, if you look at it carefully, it has all sorts of UI widgets that tell you what's going on, and everything that you need this SDK surfaces so that you can build exactly the same kind of application. And this sample just shows you all those things you can handle. One I want to point out is, because it's going to come up in the DRM section, is handling of the message WMT no writes. And just like Windows messages, it sends a message and it sends a parameter. And in case of no writes, it's going to send through the URL of the site that you need to navigate the user to. So, right. So, okay, this is a lollipop diagram showing how to use the SDK to write out a file. So it's very simple. You'll instantiate and this is what that AVI to WMD sample does. It instantiates a profile object. If it wasn't using a system profile, it would call add stream and add all the streams and say what type they all are. Then it instantiates a writer object called set output file name to say what files to write to, and then it just calls write sample and passes in all of the frames of video data and all of the audio samples. And that's it. That will get you a Windows Media file. You can use, of course, the metadata editor and all the other interfaces to do fancier stuff. You can use this network sync object if you're going to write out to the network. So for reading, it's more or less the reverse. You'll create the reader object. The difference is that reading happens asynchronously, where we want the application to implement a reader callback interface, and then from inside the SDK, we'll call on sample as the data arrives. And that's because when you're building a player that can stream data off the network, there could be a delay, and we want to call you back as soon as it arrives so that you can render it. Okay, so just going to talk a little bit about editing. We have full support to enable a audio-video editor to integrate Windows Media as a native data type into the application. And one of the things that an application should be able to do is manipulate the compressed data directly, so that if you want to just chop 5 seconds out of the middle of a long program, you shouldn't have to uncompress and recompress everything else. And because every time you uncompress and recompress, first of all, it's very slow. It takes a lot of processing power, but it also loses a little bit of quality because coding has to be rerun, and it's best just to keep the original. It's like taking a photocopy of a photocopy of a photocopy. Eventually, it doesn't look so good. I mean, for one generation, it's fairly detectable, but after a while, it would degrade. So the point is, you can access all the compressed data. You can suck all the compressed data out of a Windows Media file and write it back in, or write any subsection of it back and splice things together. And to do all that, you'll use the advanced version of the interfaces. This picture is just showing you what happens in the case where the user has imported several clips into an editing tool and has indicated that he wants some transitions between things. And the transitions happen in this case not to line up exactly with the boundaries of a group of pictures. And so you'll discover when you get the compressed data that a little bit around the editing points, you'll have to recompress a little bit extra on either side to make sure the boundary aligns with a keyframe. Okay, so in terms of what's in the header, there are these properties: title, author, description, copyright have existed for a long time, but with digital music over the last year, we've added all these tags to make sure that we have the same tags that are in, and actually superset what's in the ID3 V1 set. So you can, when you're moving content from a CD to a PC, you can record the album title, the track number of the CD, what genre it is, the year of the song, lyrics, album art, if you want, and you can throw in some URLs that the players can use to take the user to information about the content. Okay, so I'm going to go into the rights management system. This slide was shown earlier today, telling you about the goals of digital rights management. This was the high-level picture of, which I'll just remind you, you take your unprotected content, you package it, you get encrypted data, and then you can distribute that encrypted file out to users. And then for them to be able to play it, they have to, they'll be forced to obtain a license. And I'm going to go past that because this slide shows a little more detail of what's actually happening. So you have two different servers involved. The content server has the protected files, that is, files that are encrypted. It can't be played because the decryption key is not there. And its purpose is just to blast out the files to as many people who request them. But parallel to that, there is a license server, and the license server knows the key to decrypt the content. And what happens is, when the player attempts to play that content, it's going to be calling the SDK through that IWM reader interface, and it will receive the WMT no rights message, and it will be told a URL. That's what I showed in the sample out there. And what it's supposed to do then is navigate the user to that web page. And what will happen is the user, when he's at that page and enters his credit card or email or whatever the publisher wants him to enter, a unique ID for his for that PC is transmitted, and there's an ID that's generated that will not be the same on any other computer, and that's sent down. And the license server incorporates that into the license and creates a license that has the decryption key for the protected content as well as the ID of the system that it's bound to. So now the license that exists in a store on the user's machine, the place that he doesn't really have, the user doesn't have to think about it. They'll see a WMA file just like normal. And when they go to play that file, underneath the covers, the DRM subsystem will go out and fetch the license and check the rights. And the player will at that point, it's just like it's playing unprotected content. So I want to, the actual rights that can be specified in the digital rights management system are here right now. And in the future, we're expanding this because there are some more special cases that people want to be able to do. But basically, first at high level, there's just the right to play or the right not to play. Then you can say an expiration date, And you can say that when an expiration date is hit, so that you can't play the content, or you can say that after the expiration date, they can only play a preview of the content, or only a portion of the content. Then there are two additional flags that can be set. One is the right to burn to a Redbook CD. And if you think about it, if you download protected content, a lot of people own CD burners, and some of the applications enable you to mix and match and do your own list of songs and write that out to a CD. And some publishers, even though they're producing protected content, want to enable that. So they can flip this right on. And the thing to keep in mind, though, of course, is that normal, traditional audio CDs have uncompressed data and, of course, unencrypted data. So a user could, after they burn a Redbook CD, they could re-rip it back, and they'll have a piece of unprotected content, and in a sense that defeats the rights management system. So we leave it up to the publisher whether or not to allow that. I mean, if the content was just done for promotional purposes and they're not super worried about the copyright and piracy, then they may choose to enable that. But the point is, we're trying. This isn't about dictating what rights. It's all up to the publisher to decide what they feel is best and best suits their business. So the next right is the right to transfer to a portable player. And as I'm going to explain in the next talk, portable players that support Windows Media will always have decryption software on it. So it's possible to take a piece of encrypted content and keep it encrypted and just move it to a portable device. And then so long as the license is handled correctly, which I'll show you how to do in a sec, that content will still play on the portable device. So you're not exposing the content to piracy in this case. So you can indicate whether or not you want to allow content on portable players. And if you do that, you can indicate whether you allow an infinite number of transfers, or give them 10 transfers, you give them 4 transfers, or just a one-time transfer, and after they move it once, they have to go back and reacquire a license. That's all up to the publisher. So, as we've been saying, it's very, very simple to integrate Windows Media. It's also very simple to get the app to be able to play the protected content. You don't have to worry about decrypting or handling these keys or handling the licenses or anything. You do have to sign a paper license agreement that Ramiro was describing and return that to Microsoft, and that's for the obvious reason that an app that receives the uncompressed and unencrypted data needs to agree to preserve it as a protected format. But once you return this, we'll send you this special sub-library that you can link into your application, and that has a certificate, an X509 certificate that you can hand in, and it's unique to your application. And the DRM system will check that over and make sure that you're somebody who's authorized to be able to play protected content. And in our sample app, we have the code that shows exactly what you have to do, and you'll just turn on this pound define right here, and all that code gets switched on. It's not very much code. The main difference is instead of calling WM create reader, it will call WM create DRM reader. And it also turns on this code about doing the arrow flip when a license is unavailable. So this diagram sort of restates that. This is the stuff library that we'll send you that has the certificate that gives the player authorization. And this channel here between the SDK and the application, these are all compiled into, this will be compiled into one executable. But this channel in between here, all the parameter traffic is encrypted and authenticated, so that's secure. When the SDK is reading the WMA file and detects that it's protected content, it invokes the DRM system, and that goes out and looks in a special place on the guy's computer, finds the license file, checks to make sure that the rights are available. And if they are available, this will just play. And this piece I'm going to go into in a lot more detail later. But the player can also say, move this content to a portable device, and this guy will get invoked to handle that. Okay, so that's I think I'll stop there. These are the important thing here on here is this URL on the MSDN. We have a dev center under MSDN which has all the links to all the information that I've discussed here in the SDK that's in beta and will be released very shortly that you can download.